So we were able to get the standard error for adding two statistic, but that's not what we need. Remember, we wanted to compare two statistic, two distributions from two different distributions, and the way that we decided to do it is not to add it, but we decided to subtract it. And so what we really need is the standard error of x minus y. But how are we going to use this result to figure out what x minus y is? Here's how to do it. Isn't this the same thing as the standard error of x plus negative y? Right? It's just the same thing mathematically. And if we say it that way, we can see that we can have some interesting results. Notice that in our derivation, we were able to get this result from this. So this thing is actually equal to, from what we understand, as the expected value of y squared minus the expected value of y squared. Alright, now if I change it to negative y as we've seen, so the only thing that would happen is from this negative y it would be expected value of negative y squared minus the expected value of negative y squared. Of course, obviously you understand that negative y squared is just the same thing as y squared, obviously. Now what's a bit harder to prove is this, because the negative is a constant, that's -1, so it does come out of the expected value, but don't forget that this entire thing is squared, and hence the -1, what happens is this -1 becomes +1, and then we still end up with the expected value of y squared. And just copy the one in front, and isn't that the same thing as, isn't this the same thing as sigma y squared? It's the same thing. So it means for us that the equation for the standard deviation, the standard error of x minus y, would have the same formula as adding the statistic and subtracting the statistic. And that is very brilliant. Right, now what can we do with this? What can we do with this result? Remember that last time we were trying to subtract two means coming from two distributions, and we can use this result to verify what the z-score would be. So let's try it out. So our z-score is equal to the statistic 1 minus the statistic 2. Should be all over the standard deviation of the difference, the standard deviation of that statistic over square root of n. But I don't know what the standard deviation of the statistic is. But now we know because the standard deviation of the statistic is related to this. Now remember that this is actually the variance of the difference of the statistic. And so if we wanted to get the variance of this, we wanted to get the standard deviation of that, then we just need to take the square root, as I said, the square root. And so the standard deviation of x minus y, right, would be equal to the square root of the variance of x plus the variance of y.